we write it down in the way of vectors. So it's like you trick this point as 0, 0, and here is the vectors v and the vectors u there. Okay, so how are you going to get this side, which is C here? So one way is that you do the subtractions. So it says that I multiply it by a negative number here. Okay, then I will get the parallel vectors here. Minus, right? And since that, I think I forgot to mention this. So in the vectors space, you can actually like move the vectors. So this is exactly the C we want. So that's why like I put it this way, like v minus u here in the first. And then you just do the like you distribute it and do the calculations. Okay, so remember that when we talk about the node, is the inner product and then take the square root out of it. But now we directly have a power of 2 here, so we don't need to do anything here. Okay. Okay, and if we write it down this way, so this is exactly the same expressions as the here, right? A, B. So you just treat, for example, like a V as A, and like the node of U as B, and then you have the same expressions, and then that's why we can write it down this way. Okay. And notice that when the angle equals like 90 degrees, then you become orthogonal. So when you do the inner product with two vectors with 90 degrees between them, then it becomes 0. Okay. Yeah. Okay. Then is the hyperplane. Okay, so what is the hyperplane? The definition is that let's say that we are looking into a hyperplane in Rn here. So it's a subset defined by a linear equations here. Okay, so okay. So in these definitions, what is given is the non-zero, a fixed non-zero vectors A. This is given, and the B is given. Small b is given. What can be changed is the x. Okay, because we are care about all the x in this Rn space that satisfied the linear equations over there. Okay, and if we know that there is this, like, if we know that there's one point x start is in that plane, then we can even write it in this way. Okay, so why is that? Okay, so we have the fixed vectors, non-zero vectors. Yeah, does it need to be non-zero? Yeah, non-zero vectors here. Okay, and we know that the hyperplane is defined as the inner product of A and all the points in that space, and then they should have they have to equals B here. And we also know that this point x start is in that plane. So when we plug in into these equations, it should equals B as well. And then with these equations, we can, with a little bit arrangement, you can get these expressions. Okay. Okay, so there's another way to think about this one. Says that the hyperplane, we are looking for a hyperplane in R2. Okay, so a hyperplane in R2 is actually aligned here. Okay, and A is actually the vectors, normal vectors of that hyperplane, which I believe I'm going to cover later, but yeah, A is the normal vectors. And we want to collect all the points on it. And we also know that there is a point, x star, is on this plane. Okay, so one way to write it down is to say that, okay, so for all the points, for example, like x1 here, if it is on this plane, then I know the vectors construct by these two points, which is x1 minus x star. And when it do the inner product with the normal vectors here, it should equals 0, because that's how the normal vector is defined. It has to be orthogonal to the hyperplane. So that is also one way to think about it. And because we want to know all the x, so actually you don't have to pick up a certain point. Like for all the x that satisfied these equations, then it must be falls on this hyperplane. So that's another way to think about it. Yep, and this is some tips or like help you to save your time. So hyperplane in R2 is aligned, and in R3 will be a plane. Okay. Okay, then is the convexity and concavity. Now we first look at the convex set, which is quite important in the economic field. Okay, so a set is called convex set, C. If for any 2 points in that set, and you put a lambda, which is between 0 and 1, and you see I will also call it linear combinations. I don't know whether that is a good way to call it, but a linear combination between these 2 points, between these 2 points. Okay, it's also within that set as well. Okay, so how does it look like?